All right, guys, we're going to first go over our homework from last week. Make sure that you pause if you need to look at it a little bit longer than I scroll. So if you need to pause now, you notice the red is the pre-image, and then obviously the rotation or the translation is the blue, and then 6 is the green is the rotation. Here is, I'm going to shrink this a little bit. There we go. And obviously you can see the pre-image and then the reflection, and then obviously you're going to translate you're translating it 3 and up. So number 2. And finally number 3. Oops. So the pre-image, obviously you dilated and then reflected. Remember that I asked you for the remaining is for the grid logic, you could do Sam, you could do any of them. Obviously, here's Sam was playing a game. And what are the coordinates of the other 3 vertices? So obviously, those are the other 3 vertices. You did Sam's. Here's another grid logic on Ann. And remember that it does vary with your answers depending on where your corner is being slid. So it all depends. So that's kind of how one example is for the Ann. For Joey, answers also will vary. So keep that in mind as you look at yours. I'll look at yours individually. And then Susie, on the other hand, her garden was a parallelogram. So remember what a parallelogram has to be. It cannot have 90-degree angles when you connect the points. So, but 2 sides have to be parallel. So that's the slanted. Looks like a rectangle but slanted. So, well, I hope just make sure that you either hand this into myself or Mr. Bolin before you leave class today. If you have any questions, make sure that you can ask Mr. Bolin questions as well. Now what I want you to do, we're going to start functions, and if you would, I want you guys to go to, hang on, we need to go to function. You need to go to your notes. They should be input-output tables on the front cover. On the second page, you should see some graphs and something about what I know about functions, and then page 36, inputs and outputs, where your homework will be. So I'm just waiting for it to load, and we'll start. So hopefully you'll get while you're waiting for me, you can get things together. All right, I think we're good. Maybe not. All right, so what are functions? And we're also going to see how much time we have and maybe introduce some direct variation, but that's probably most likely you guys will watch that tomorrow. Introduction of functions. First of all, functions are obviously through this lesson you're going to figure out what a function is. When you look at a table, how to identify a function. When you look at a graph, how do you identify a function? And then equation, how do you identify a function? So all three I call it the trifecta: the equation, table, and graph, making sure that you just, like a good quick, your goal is you should be able to identify quickly all 3 of them if something is a function or not. So what we're going to start with is a function man. Come on. There he is. Whoops, sorry. You have obviously the input-output that's on my screen. I have this guy. And what happens is just pretend that this is a function. This function man is a machine, and basically I'm going to take these numbers and I'm going to put it into the function man, And if you notice where the out, which is the, obviously the right side of my screen, the number will come out. And that's how you fill in your table. So like, for instance, your input right now in your table is -4. So I'm going to take -4 here. And when -4 is put into Function Man, look at what comes out. You guys all see -20 down there on the out, right underneath the out. So I want you to put right across from -4, -20 for the output. Okay? So now what happens is what we're trying to determine is if you put something into the machine, can you figure out what's coming out and find a pattern? Okay, so we're going to do another one. And obviously 0 goes in, 0 comes out. You guys should be filling out the table. And that's something that I'm going to be looking for. Now, 2.1, 2 1/10 is going to go in. Now watch what's going to, something is happening. Some operation is happening to make it get to 10.5. That's what we're trying to figure out. What kind of operations would it take to get to 2.1 to 10 and 5/10? Now, some of you might have it, okay? Also, we're going to do one last one, see if you guys can get the pattern. So we're going to put 3 in, and we get 15. All right? So now, obviously, your table should be correct me if I'm wrong, -20, you should have 0, 10 and 5/10, and then 15. All right, so I want you to think about input output can also, if you notice the table, think about what input and output values would be. This would be your X and Y coordinates. So like if you plug in -4, think about the function, we've already actually done a function before. We called it a proportional equation or graph. But X, if you put X in, what did you do to X to get to Y? What did you do to 0 to get to 0 for Y? What did you have to do? What operation would get you from 2.1? There's a pattern here, okay? When you take 4, what did you do to get to -20? There is an operation. It could be any of the 4 basic operations. It could be addition, but it has to work. The main thing is it has to work for here, 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 just like when you had a common ratio. The rule has to work for every single input value, and it would match up the output values. So right now I want you guys to think, what kind of rule? So I want you guys to maybe see what kind of rule would you make, would mean an equation that would match this input-output table. And what I'm looking for is y is equal to something. Your output, y is equal to something. So what did you have to do to x? And what we're going to do is I'm going to go back to my function man and unreveal the rule. If you want to pause to see if you can figure it out, you can do that. Otherwise, I'm going to reveal the rule right now. And the rule is y is equal to 5x. If you notice, everything that you put in, -4, you got -20 coming out. Okay? So that's -4 times 5. Ooh, come here. Come back to mom. There you go. All right, and then you put 0 in. Obviously, 0 times anything is 0. So 0 there. That should be that should identify that, you know what? Probably multiplication's involved. Because if you, think about what's going to happen when you multiply. You have to get 0. If you added 0, it would turn to a different number. So there's some indicators that would mean multiplication versus addition or subtraction. Okay? So all those numbers that fits that rule. So any x you put in, you're obviously, we need to, my hat. Okay, I need to. All right, let's go to the next one. Let's not save it. All right, so right here, so right here, you guys should have written y is equal to 5x. Let's go to the next one. The next input value has -5, 0, 2, and 3. So the first, remember you can also, right above input and output, you can put x and y again. So when negative 5 goes in, negative 14 goes out. I mean, some of you are probably saying, well, obviously, it's not just multiplication, because obviously you can't take negative 5 and multiply just one number and get negative 14. So there's something else is obviously going to have to be involved. 0, if you put 0 in, you got the number 1. So when you guys look at that, obviously 0, think about how you can get 0 and get 1. Obviously multiplication, just multiplication wouldn't work, so you maybe think about a combination. 2, how'd you make 2 get into 7? Okay, and then 3, when you put 3 in, you get 10. And my 10, and then my thing just went bye-bye. So, I'm going to move on here. My screen, it's not working. All right, so negative 5 turned into negative 14. This turned into a 1. 2 turned into a 7. And 3 turned into a 10. So what you have to think about is, you know, obviously just multiplication can't work. Addition, only addition can't work. It doesn't work for all of them. Division does not work. So you might want to think about maybe a combination, like maybe multiply then subtract, multiply then add, divide then add. But it has to work for all of them. Take a minute to see if you guys can figure out the rule. Pause as well, because I'm going to stop at this screen. I'm not going to I can't go back to the other screen. So the rule, hopefully you should see that if you multiply x by 3, come on, here, hang on, by 3, you should, not negative 3, okay. So if you multiply by 3, this would, for negative 5, negative 5 times 3 is negative 15, but to get it to negative 14, you'd add how much? Hopefully you're thinking 1. So 0 times 3 is 0, plus 1 would give you 1. 2 times 3, which is your x, would give you 6, plus 1 is 7. 3 times 3 is 9, plus 1 is 10. So the rule for this table or that machine would be 3x plus 1. All right, the next one is negative 1, 0, 1, 2.5 for our inputs. So let's try the first one. So we're going to take negative 1, take it out, you get 4. Okay, so when you put it in, it's 4. When you put 0 in this time, you get 4. Oopsies. Okay, when you put 1 in, you get 4. Two and a half. Anyone want to predict? Anybody want to predict what this would be? 4. All right. So as you guys look at that, so all of them are 4. So, you know, if you notice that if all the y's are 4, okay, you guys should have this filled out. Negative 1, it was 4. 0 was 4. 1 is 4, and 2.5 is 4. So does it matter what x I choose? What is our output always going to be? What is our y going to be no matter what? 4. So in this case, this is the function y is equal to 4. Because y can only be 4. All right, the next one. Okay, we have 3 inputs. You have 4, but if you notice, I'm going to show you 2 things. Now we're going to put 4 in, and look what comes out. 2 and negative 2. Okay, so if you guys put that down, so 4 is 2 and negative 2, 25. When we put 25 in, it's 5 and negative 5. And then 36, when you put that in, somebody might maybe can figure out the pattern, is 6 and negative 6. Okay, so when you fill out your table, 4 was 2 and negative 2. 25, I could put 5 here and negative 5 here. You could also list it that way. We could have 2, we could put 4 down here too, and one of them would be 2 and one you could put negative 2 down here. It doesn't matter. 36 was negative 6 and positive 6. So at this point, can you figure out the rule? What would you have to do to all your inputs in order to get 4 to 2 and 2 or negative 2, like you took either one, 25 or 36? And think outside the box for this one. Okay? Pause if you want to figure it out yourself, otherwise I'm going to write the rule now. The rule is actually y is equal to the square root of x. Because if you think of the square root of x, the opposite of squaring is, or opposite of square rooting is squaring. So you guys agree that if you took 2 and squared it, and then negative 2 and square, you'd get 4 for both of those. Negative 2 times negative 2 is 4, 2 times 2 is 4, they're all that. So then if you want to go backwards to undo the squaring, you square root, which means that perfect squares have 2 answers. Okay? All right, let's go to the next one. You notice I have my computer today, so it's a little slow. Sorry about that, but that's all I got. All right, so this one, we got negative 5, 5, negative 2, 6, and 7. So let's start with negative 5. We got 25. Put negative 2 in, you got 4. Five, 25 again. 6, 36. And number 7, we got 49. Okay, so go to our table. We have 25 here, we have 4, we got 36, and then we got 49. So what are we doing to our x every single time to get to our output, which is our y? Pause if you want to try to figure it out, otherwise I'm going to give you the rule. Every time you've taken x and squared it. So 7 squared is 49, 6 squared is 36, negative 2 squared is negative 4, or excuse me, is positive 4, because you'd write it like this. Okay, just be careful with that. And negative 5 squared is 25. Okay? All right, we have one more table, and then we're going to go back through and decide if these are functions or not by looking at a table. All right, so first of all, all threes on our X, or which is our input this time. So here we put a 3 in, 1 comes out, 3 goes in again, we got 8 and 45/100ths. Now we got 2 numbers coming out, 153. Does it matter? We could have any of those numbers come out. So right now, I want to ask you guys something. When I put a 3 in this machine, do you have any idea what's coming out of that machine? Because in the earlier machines where I put the numbers in, you started seeing patterns, okay? And what happens is when you put the number in, before you know what's going to come out, you have an idea. You know exactly what's going to come out, okay? Like if you multiply by 3, add 1, you know what number's coming out as long as you know your input. But these 3s, think about it. If I put a 3 in, do I know exactly what's coming out? And hopefully you answered that no on that one. That's going to help us. So, I mean, we had negative 42.3, we had 8.45, we had a 1, we had 153. I mean, these numbers are random. There's no real pattern. So, in this case, instead of y is equal to 4 like the last one, where if you remember the output repeated here, if you notice all of these repeat. So x is 3. That is the rule. Because that's only, y can be anything, x has to be 3. Now, I'm going to go back. We're going to go back and I'm going to share with you something, the rule, and I want you to write this definition down. I don't care, it's on the top of your page, on the bottom of your page, I don't care, on a piece of paper, but what you need to understand is what is a function? What's the definition of function? So let's start with, we got one more here, 14. All right, so we're going to start here. What is a function? A function is where you have, for every x value, you have one y value. I'll repeat that. A function is where for every x value, you have one y, which means it's a 1-to-1 ratio, okay? And the easiest thing that I can tell you, you might want to write this down also. If you want to look at a table and if you want to know, okay, is this a 1-to-1 ratio? If that's too hard for you to understand what that means, I want you to ask yourself, could you look at just these numbers right here and ask yourself, does the x repeat? If you say no, it's a function. If it repeats, it means that that x value has multiple y values that go with it, which means then it's not a function. So does x repeat? Just go to the x input column. Does it repeat? Does this repeat on this page? Negative 4, 0, 2.13. Nope. So if you would, write function in that slide. Okay, that is a function. Let's go to the next one. Here's this one. Does your inputs repeat? Do these repeat? No, which means it is a function. As long as the x does not repeat, it is a function. It means that there is a 1-to-1 ratio. There's negative 5 has one value, output. 0 has one value. 2 has one value to go with it, and so on. Let's go to the next one. Is this the... Now this one, if you notice, you circle the x's, okay? These do not repeat, so is it a function? Yes. But then you're probably saying, well, Mrs. Ohms, the outputs repeat. What did I say can't repeat? The 4. If I put 0 in the machine, 4's come. We know what's coming out. As long as you know what's coming out, it's a function. Exactly, because any number, any input value that we put in to this little function man back here, we know that 4 is going to come out. We put it in, 4 is coming out. We know. And I'm going to leave that alone because he's messed up. He's functified right now. So we're going to just keep going. All right, how about this next one? Okay, so you circle your inputs. Do they repeat? Yes. Not a function. Not going to work. It means that this x value has 2 y values. 25 right here, look, has 2 values. Okay, look at 25 goes to this one and this one. So it's not. 36 also has 2 values. 4 has 2 values. It's not a 1-to-1, it's 1-to-2, which means that's not a function. Let's try this one. Do our x's repeat this time? No, so is it a function or not? Remember, x's cannot repeat. It is a function, hopefully. It's starting to click. And last but not least, I want to ask you guys something. Do the x's repeat? Absolutely. Can they? No. Remember what I asked you on this slide before. I asked you guys, when I put the 3's in the function man, did you know what was coming out? Did you know that it's going to be a certain number? When you don't have a clue what's coming out, ladies and gentlemen, it's going to be not a function. So again, not a function. So again, the definition of a function, that there's, for every x, there is only one y. And the easiest way to tell if a table is a function or not is to go to the input or the x and ask yourself, does it repeat? If it does, you're good to go. Okay? I'm going to. All right, so now we're going to go on to graphs. So we're going to do something that's called the vertical line test, okay, right here. And obviously, I sure hope everyone understands that a vertical line goes like this, okay? And how this works is this. If you take a vertical object along all these graphs to determine if there's a function or not, basically make sure that it does not cross more than once. If it crosses more than once, that's where at those sections that this vertical line, come on, okay? I'm going to take this vertical line right here. Sometimes, a lot of times when I have the classes, I have ruler up here, and you can see the ruler going across. You guys agree the blue stick is vertical. Okay, there's a vertical line right here. You move it across, and you ask yourself, hang on, I don't want to move that. Okay? I want to move this. Okay, it's not working. And if I move this little guy right here, okay? If I move this, how many times does that cross that red or that graph? Hopefully, it only has one intersection point. It's crossing right here, okay? As I move it along, it only crosses how many times? Come on, where's my thing? There we go. Okay, so as I move it across, it only intersects the vertical line, the graph, once, all the way across. So as long as it only crosses one time, this is indeed a function. Okay. Now as I move the graph on to B, as long as I can get my
There we go. All right, so here, if you notice, I'm going to move it right there. Right there, how many times does the blue line cross the graph? I sure hope you're seeing one time here, one time here. Do you guys see how these points overlap? This means that, think about the ordered pairs. Okay? Think about this as 1, 1. Think about this as 1, 10. What do you notice? Does anybody notice the fact that the ones repeat? Aren't these your x's? And can x's repeat? We just talked about that in tables. Can the x's repeat? No, which means this means the graph is not a function, because in the graph, it can't repeat. It means that when the dots are overlapping each other, it means that the x points actually have the same x coordinate, which means that the x's do repeat, and it is not a function. The next one, I'm trying to get my thing to work here. All right, here we go. All right, so now I'm going to bring it over to here. Hopefully you guys will notice that right here, it crosses once, crosses once, crosses once. But what about right there? Think about right there, at that little section right there. Don't you have points that are right here? And what did we discuss about points that are on top of each other? They're on directly vertical of each other, which means this here and that here have the same x. So the x's repeat. So is this a function? Well, it's not. Obviously, if that section right there was eliminated or not within the graph, that perfectly vertical section wasn't there, it'd be a function. So if you notice, if you have a graph that has any sort of section that is vertical, like this right here, it's going to be not a function. Now, I'm going to bring my little thing back up here. There we go. All right. Now, we have right here. Is this a function here? What about where those two dots are? You have overlapping dots right here. Okay? But is this a function? Remember what the open dot means versus the closed dot? Remember inequalities? Remember the open dot means that we don't include it, but the closed dot means we include it in our. So is this a function? Yes, it is. This is a function. Now, how would you make this not a function? I mean, think about that. What could you do to the graph to make it not a function? Well, what if you filled these dots in? Now would it be a function? No, because look at those dots are now filled in. Now you have dots that are filled in directly above each other, which is vertical, which means anything that is vertical in a graph is not a function. It has the same x values. Oops, I just ruined my line here. All right, how about the next graph? Is that a function? How many times does the vertical line cross that graph? Three. Can it cross more than once? No. Otherwise, what happens here? What repeats? Hopefully you're thinking the x. So is this a function? Not a function. Okay? Now, when you bring your vertical line onto this graph, okay, we have one time, once, crosses once, crosses once, crosses once. So all the way across, going, from left to right. Remember, vertical line test. Remember, takes a vertical object or a vertical line, your pencil, your pen, your finger, across left to right on a graph. As long as this blue line only crosses one time, which means that the x's do not repeat then, if it only crosses once. But if it crosses more than once, obviously over here, means every time it crosses, the x's repeat. So with the vertical line test, it only can cross the line or intersect the line once. So this is a function. All right, now, what I'd like you guys to do is turn in your third page. And I would like you guys to try 1 through 12 on page 36. It's the second page, obviously the second stapled page. And there's some tables there, obviously. You need to describe the rule, if you try to figure those out, if it's a function or not, okay, which is number 5. Okay, so the rule is 1 through 4, 5 is, are they functions? 6 through 9 is, are those graphs function or not? What we just did on the screen. Think about the vertical line test on those. And then 10, 11, and 12, you do your best with explaining those questions. All right, guys, well, thank you. I'm going to record the direct variation 2 as well, but there'll be 2 separate videos, so I will talk to you guys later. If you have any questions, please make sure you ask Mr. Bolin or myself before you leave today. Thanks, guys. Have a great day.